Today, I'm going to talk about some subjects that we thought would be of interest to you. However, during the talk, the chat is going to be open, so please feel free to bring up other questions and other things in the chat. And I believe that Victor is going to kind of moderate the chat so that as questions come in, we'll figure things out. I have been in technology for a very long time. And as I look around at the names in the room and I looked into and learned your organization, I'm very, very excited to be able to talk about technology with all of you. So thank you very much. So without further ado, I think I'll start my presentation. Does that sound okay, Victor?
Yes, please.
Okay, so let's see if I can get this technology right here. So today I'm here to talk to you about databases and culture. And I've been, as I'll tell you, I've been working in databases for a very long time. And I've also been a leader of people for over 30 years. And I think that the two things together are both very important topics for professionals and executives in the IT industry. So today I'm going to talk a little bit about what's been going on with the evolution of data over my career. And then we're going to pause for a question and answer session right then. You can ask questions then, or you can wait till the end. The second thing we're going to talk about is just a little bit about MongoDB. And I want to be really clear. This is not a sales pitch by me to you. This is meant to be a technology pitch. There are people on the call who would love to talk to you about buying MongoDB. I, however, am not one of them. We have some people from MongoDB who would love to chat with you about that too. I'm here to talk about technology and how technology has affected all of us and all of our businesses. And then third, I'm going to give some thoughts on culture and why I believe that engineering culture is actually one of the most important things for us as leaders to talk about. So without further waiting, I'm going to talk about the evolution of data. But the very first part of that is I'm going to talk about the evolution of Mark so that you actually have an opinion on why you're listening to me today. So I started my career as a programmer when I was 12. I got my first paid programmer job when I was 16. And then I moved on to either working with data as a user or creating systems that manage data as a provider. So for example, in 1984 to 1988, I used huge amounts of data in my jobs at NASA and the Department of Education for the United States. I then moved to Oracle for 13 years, and I built versions 5, 6, 7, and a little bit of 8 of the Oracle database system. And for those of you who might have used Oracle Parallel Server or Oracle RAC, as it is now called, I was one of the people who built that. I then moved to using data. I retired. You can see a big gap on my schedule. I retired for 10 years and did other things that were non-database things. I had some kids. I moved a lot and had a lot of fun. But eventually, IT pulled me back in, and I worked for News Corp and the Bill and Melinda Gates Foundation, and again, used data as a customer. I then moved to AWS, and I produced Amazon RDS and Amazon Aurora and the database migration service. And then I moved to Grab, which is the Uber of Southeast Asia, where we were doing over 10 million rides a day, 1,400 databases, and just doing amazing things. However, what then happened was I came back and I decided I wanted to build databases again. Now, wow, lots of interesting stuff there. Databases are the thread through all of that. I believe that databases provide some of the most important promises in the data systems in terms of durability, correctness, availability, operability, scalability, and availability. And what that means is that these are some of the hardest problems in computer science. They're harder than writing applications. They're harder than writing operations layers. They're the layers that when the database is down, as you all know, basically the customer is down or the website is down. And so that's been my passion my whole career. So you might be wondering, what is this relational database guy doing at MongoDB? And I'm going to tell you a little bit about that. In all of those years, there's one trend that I could always count on, and that has happened again and again, which is that global data volumes have expanded exponentially. You can see on this chart from 1990 approximately through 2020 how the global data volume has expanded exponentially. And on the left side, you see an actual logarithmic chart that takes us from exabytes to zettabytes to yottabytes. It's almost unconceivable today that in 1990, people thought that there might have only been 1 exabyte of data in the world. And yet now an exabyte is an amount of data that might be processed by any one company, a large company. Now, this is important because computer technology has had to keep up with this data growth. And as you look at this torrent of data, it has created opportunities and challenges over the last few decades. And relational technology, what I actually cut my teeth on, has been an amazing technology, but it has had some challenges. So a little bit of history. Relational technology was founded in 1970 by a gentleman named E.F. Codd with this massively important paper called A Relational Model of Data for Large Shared Data Banks. And what he focused on in this paper was that these programs, for the very first time, had to be protected from now knowing how data was organized in the machine. And there had to be this normal form of database relations, and there had to be this uniform language, which ended up not in 1970, but by 1978, actually 8 years later, being called SQL. And so the paper was in June of 1970, which I'm going to point out was 52 years ago. And that is unbelievable when you think of what other parts of computer technology are still relevant 52 years later. By the early 2000s, the limitations of relational were becoming painfully obvious. And rigid to change, when you create a schema in a relational database, it imposes unnecessary constraints for developers. In other words, relational technology was all about the computer. It was all about controlling the data. It wasn't about the developer. The developer had to learn to speak the language of SQL, had to learn to speak and not duplicate data, and had to be able to speak in the language of the computer. It didn't cope well with unstructured data, even though the vast majority of data today and back then is unstructured. Over 80% of the data that we deal with in our applications is not amenable to being stored in rows and columns. It's very difficult to scale, and in fact, every major database today, with the exception of Oracle Exadata, does not do well with having multiple writers of data. They only do well with having multiple readers. So if you think about Postgres, where you can have one writer and you can have multiple readers, which means that as your application expands, you hit limits. And not only that, along the way in the early 2000s, the internet came along. And now rather than having a database that might need to scale by 2x per year, you might have an application that needed to scale by 1,000x. And relational databases struggled. And so relational, as I mentioned, depends on the performance of a single machine and the scale up of that machine. And this chart, which I'm putting here on the screen right now, shows that through 1995 to 2005, the capacity of machines was scaling at 52% a year, which is pretty unbelievable. And a very interesting step change occurred around 2004, 2005, which is machines started scaling at only 21% a year, which is huge. Again, there's a logarithmic scale on the left side of the graph. Now, the funny thing about this graph is that MongoDB and many of the other NoSQL databases were created right about here in 2005, 2006, 2007, when it became clear that data volumes were scaling, the need to compute on that data was scaling, and yet machines themselves and the technology that those machines were using, relational technology, was not scaling. And so in 2007, MongoDB's founders actually hit these limits of relational technology. They were trying to produce a system that would process 400,000 transactions per second to do advertising, and Oracle itself could not do it. And so they set out to build the world's best modern general purpose database. Now, for those of you who know MongoDB's history, I won't lie, they had a rough start. They started out and they overpromised what their product could do. And by 2012, a lot of people were saying MongoDB is not a mission critical, reliable database. These people are overpromising. But it could easily process 1 million transactions per second, but in an inconsistent or eventually consistent way. So over time, what happened was all of those things came together into an awful lot of data, processing not being able to do it, and then new technologies like MongoDB, Cassandra DB, Couchbase evolving. And what I'm going to show you in the next session is how MongoDB adjusted to those challenges. But in the meantime, I'll pause here, and I would just love to take questions. And so I'm actually going to stop sharing my screen so I can see your faces as you ask questions, and we can go ahead and take questions for a couple of minutes.
Mark,
Mm-hmm.
we have a question. Actually, I think we have the following case. There's a need to build a relational database or apparently relational SQL with features. Many people will be able to add information, registers or records, but no one will be able to make non-authorized use of the data sets, including a copy of it. This could be named as distributed database with distributed control. The question is, how can MongoDB or maybe blockchain technologies can be used to build such a database? What will be the best option?
So that's a great question. One thing that's kind of missing in my evolution of data is a lot of the things around authorization and protection and cryptography and all those things. And I'll get to those a little bit more. But let me answer that question directly. Blockchain is a really interesting technology where you can commit multiple transactions per second, but it's not many. It's 6, 7, 10, 12 transactions per second. Ethereum, I think, allows up to 30 transactions per second on their blockchain that allow you to commit immutable transactions. And that is incredibly valuable. However, the problem is these technologies rely on a mix of decentralized and centralized technologies, and no one, to my knowledge at least, has yet been able to build systems that might process tens or hundreds of thousands of transactions per second. So my personal opinion is that blockchain is really important for committing batches of immutable transactions to a ledger, but for typical OLTP transactions occurring inside companies, we really need to rely on traditional technologies such as authorization, authentication, encryption in rest, and encryption in transit. So I think those are really important. Now, I want to be really clear here today. I am not in any way saying relational technology is not a great technology. I mean, I helped build Oracle. But I do believe that lots of technologies, including MongoDB, have their place. So I see a hand raised from Luis. And maybe Luis, Victor, I don't know if Luis wants to ask a question.
Please.
Yes. Okay, thank you. Thank you very much, Mark and Victor. Yes, well, let me just get this question straight, because I actually sent this question that Victor just read for you, Mark. The use case is the following. Well, I will give a very little background, and just to try to make myself clear. last year when vaccination, anti-COVID vaccination started in Mexico, no, the government, the federal government, came out and asked everyone to register in order to get the vaccine.
Mhm.
Okay, they would ask you for your name, some data, your name, your CURP, which is a number that pretty much every Mexican citizen that is involved in economic activities and that pays taxes, has and some data. Yeah. Also, but they were also asking for an email of yours and a cellular phone number, no, and your address. Well, at that time, many people suspected that since the federal elections for the Chamber of Deputies, which is the Chamber of Representatives, the House of Representatives equivalent in the United States, were coming. We are talking about beginning of 21, and in June there would be elections. Many people were suspecting that government could make or could misuse that information, and use it not only for the purpose of vaccination, which was the stated purpose of it, but also, for instance, they could use these cellular numbers or email accounts in order to send propaganda or
Right.
yeah, for the party that is in power. Okay. So, I started to think how to solve this problem. How to solve this problem. I mean, how? Technically, not politically, of course. Technically, from a computer science standpoint, how we could solve this in order to be able to build a system with a database that could be fed by everyone, all the citizens that wanted to get the vaccine. Good. As you said, there will be many writers, many writers, millions of writers of information.
Mhm.
But how could we make sure that even this entity or this person that was in control of that database that was being created could not be able to misuse it? And that's why I wrote they could not be able to use it for different purposes other than what was stated. I don't know if I'm making myself
Yeah.
clear.
So I mean that's obviously a rules question, right? I mean, if the government body that was collecting all of this data or the companies
Yes.
collecting all this data, one of the things we actually offer, and thank you for the question, is we actually offer a feature called field level encryption, which allows you to store your data in a database in the cloud, in the public cloud, if you wish, and yet only you maintain the keys. And even the operator of the AWS or Azure or GCP, or even those of us at MongoDB, we can't decode that data. So the keys stay within the customer side. And one of the things that's really important about this is the searchability of that data. And over the next maybe 6 months, we're going to be releasing even more features which allow the owners of that data to keep control of that data. And yet the places like the cloud providers or MongoDB, even our cloud service, won't be able to do anything with that data, but you'll still be able to query that data and log that data. So it is a very interesting problem. And obviously, I think a lot of what you're saying, though, has to be dealt with through regulation and privacy controls.
Yes, yes, probably, but I was trying to find, since we cannot trust sometimes we
Right.
cannot trust even the body governments. No, I was searching for a technical solution
Yep.
for this. So if along the talk you can provide more insights towards this problem, I would be very grateful. Thank you very much.
Okay.
Thank you, Luis. Thank you, Mark. Thank you. There's no more questions so far.
Okay, so I'm gonna continue with my section here. Hold
Please,
on just
thank
one second while my where did my presentation go? Hold on just one second. I hate it when that happens. So let me get back to sharing with you. Sorry, Google is being very strange right now. Hold on just 1 second. Zoom does not want you to share full screen twice. There we go. I've learned my lesson. So the next thing I want to talk about is a little bit about MongoDB. And to your question, I think it was about data protection. I'll touch on that a little bit. So one of the things that's really interesting is that traditional relational databases are awesome. They have an expressive query language, they have ACID transactions, and they have enterprise security and data management. And one of the things that relational brought was this concept of all of these things on the left and people building unbelievable data applications on top of them. Now, NoSQL came along and added native data structures and idiomatic drivers. And for those of you who don't know, when you program MongoDB or some of the other NoSQL databases out there, you actually just program in the data structure of your language. You don't convert things to SQL, you don't do something new, you just declare your data structure in your language, and then it is automatically put in the database and retrieved from the database. In addition, MongoDB lets you scale out. So via sharding, you can actually just add more and more data and more writers. One of our customers, as an example, they run a system where they have over 1,300 nodes in a single database of 400 shards. We have other customers who have over a petabyte, and that's not a terabyte, a petabyte, 1,000 terabytes in a single database. And that database is 20 shards of data running on 90 nodes. And then the other thing that NoSQL let you do is rather than having to run in some large data center, you could run on your laptop, in your data center, or even multi-cloud. And if people want, at the end of this presentation today, I will show you creating a multi-cloud, multi-data center database. We could do that at the very end if we have time. So MongoDB worked very hard to build the best of both worlds. And we put these things together into a mission-critical general purpose database. And so I really want to say today, one of the reasons why that relational guy who I talked about, who did relational databases for 25 years, came to MongoDB, is I really think that we have a product, and I'm saying this just genuinely technical person to technical person, that changes the way us as executives build software. With NoSQL, you can build applications more predictably because your schema is more flexible. You can scale them more predictably because scale out is built into the system. You can keep them alive and available because high availability is built into, as an example, every MongoDB cluster when it starts has 3 nodes in it by default. Oracle, SQL Server, MySQL, Postgres, name your database, none of them have it. And so as an executive, what you want to do is you want to be able to take on the challenges like a COVID application, like a e-commerce application, and you want to know out of the box that it's going to be durable, it's going to be correct, it's going to be available, it's going to be operable. So that's what we do at MongoDB. Now, the strengths we have, which I've gone over, are that you can run anywhere. We run on 11 different cloud providers, and that is AWS, GCP, and Azure. We also run on OVH. We run on sovereign cloud providers such as OVH. We run on cloud providers like SAP. We run in China on Alibaba and Tencent. And so that's really exciting. We also let developers run on their laptops. We have a native distributed architecture where by definition, when you stand up MongoDB, you stand up 3 nodes, like I said, but you can also stand up hundreds of nodes. The developer experience of MongoDB is that you can code in your language. We support 14 different languages out of the box: Python, Rust, C, Java, Node. I can list them. And so developers, we meet you where you are as a developer. We have next-gen security. We integrate with the cloud providers identification and access methods for all the 3 major cloud providers. We also let you run on your on-premises in your own Kubernetes cluster if you want, with our Kubernetes operators. And so you can build MongoDB into your own experience. We also offer, and I'll get into this a second, an integrated experience across all of your different applications. And finally, we launched with something called the document model, and it remains a strength to this day, which is JSON, which is now, we started with JSON back in 2006, 2007, and it is now the way people interact with data. It is human readable, it is computer readable, and you can just add a field to a JSON document without changing anything in your application. Now, that sounds kind of scary to a lot of relational people, and it sounds kind of scary to a lot of CIOs and CTOs. You can also still enforce your schema with JSON schema enforcement if you wish to. So the way a lot of people use MongoDB is they get going with run anywhere, they stand up their documents, and then as they move to production, they lock down their schema just like they do with relational. Now, like I said, you can consume MongoDB in all these different ways, and you can move between these ways, because as much as we hate to say it, once you choose a data platform, it's really important not to change it because it's expensive to change it. It's expensive to retrain your developers. It's also important to be able to figure out different parts of your company and where you want to run. So the same MongoDB can run on your mainframes, self-managed, database as a service, all with exactly the same APIs. And here's the proof. I'm going to tell you today that MongoDB, this slide is actually out of date. We have over 240 million downloads of our open community software. Not the enterprise software that I probably want you to buy, but the actual community software, the software you install by saying brew install MongoDB or apt-get or yum MongoDB. And that's kind of interesting, 16 years, 240 downloads. Here's another interesting number, 100 million downloads in the last 12 months. And here's another interesting number, over 12 million downloads last month, which means that we are running at a download rate that is going up and to the right. Now, I'm not here today to tell you my product is the best database on the planet, but I am telling you that developers are telling us that we have something going, because we're now running at a run rate of over 150 million downloads a year, even though we've only had 240 million downloads in the whole company history. We have over 2 million clusters that run in Atlas. We have, this slide is also out of date, we have over 33,000 customers, and we have hundreds of customers who are spending over $1 million a year with us. Developers love using MongoDB. And for all the reasons I've said about it being intuitive and flexible, we are consistently voted the most wanted database on Stack Overflow. Now, that's really important because if your developers are happy, they're going to produce software more predictably. You're going to have higher retention of your developers. They're not going to go move to some little startup. A lot of you are CIOs of large companies, and you need to retain your developers, and you need to keep them on the leading edge of technology. And so what we've done is we've taken that core database, that document model with that unified interface, that's the green part of this slide, and that supports key value, it supports GraphQL, it supports relationship with joins. I mean, God forbid the guy here talking to you about NoSQL databases just use the word joins. With our $lookup operator, you can do joins between collections. We have a geospatial code, we have time series, we have object-oriented programming, and that's the core of MongoDB. And with that, you can do transactions and all those things you're used to. However, then we innovated in some really major ways to help developers, which is the focus of our company. We added search, but we didn't add search by writing our own technology. We used open source Lucene, and we didn't make you stand up your own Elasticsearch cluster. We actually added search right beside the database. So if you want to add search to your application, and we all know that every application today on this device needs search, it actually uses the same data store. No copying of data. It just builds search indexes right there on the core data. We also added real-time analytics, which use AWS S3 as a data lake. We also added the ability to do real-time analytics on that data. And we also added a mobile solution where you can go and build applications that sync directly to MongoDB. And of course, like I said, it's multi-cloud with the distributed architecture. I don't know what those two blue lines are on the slide. That was kind of a surprise. We have one interface for any application anywhere. So now I'm going to pause. I've given you the only part of this talk today, which is a sales pitch, which is about MongoDB. And I'm eager to take your questions on MongoDB. I also want to say that this is the beginning of a conversation, not the end of one. My contact information will be at the end of this presentation, and I would love to talk with any of you in email or on LinkedIn or otherwise. So I don't know if the rest of you see this strange blue line on my screen. I'm going to pause and stop sharing.
Yes, we do.
To hopefully get rid of that strange blue line on my screen. It's not actually on my slides. There, I'm going to stop sharing. So now I would love to take questions about why MongoDB.
There's no one in the chat, so I don't know if somebody wants to.
Yes.
ask
Mark,
directly.
I have a question, please. First of all, thank you very much for this wonderful information. What do you think about to have MongoDB on premise? Is that an option?
Yeah, so that's a great question. So MongoDB was founded as an on-premise database, and we have something that's called Enterprise Advanced. And we run, and I got to tell you, just technical person to technical person, I certify, I believe, on somewhere north of 40 different operating system combinations. So in the cloud, I only run on one operating system, the one I want to run on with my cloud solution, right? Which turns out to be a Linux variant. However, you can run on any of the major distributions with MongoDB on premise, and that part of our business, believe it or not, is still growing. And I don't have the number handy, but I believe the number is that business is growing still at 17% a year, year over year.
Yes, believe it or not, I am bringing that from AWS to on-premise. For that is my question.
Oh, that's awesome. So by the way, I am all in on on-premise. There are lots of really great reasons to run databases on premises today. And I know there's this whole belief that everything is going to the cloud, but there are really good reasons for some companies to keep running on premises.
Yes.
So I do see one question in the chat. Victor, do you want me to just take that one directly?
Sure.
So the question
yes.
is from Alejandro, which is, do you consider MongoDB a good replacement for data warehousing solutions?
Yes.
And the question, my answer is not right now. We actually are very focused on OLTP, which is online transaction processing, and we're not really focused on these, multi-hour, multi-day queries on, many, many petabytes of data with thousands of data items or features. We are moving that direction with our roadmap. There's no doubt about it. But right now, no, I would even advise you to use some solution like a Snowflake or something like that. But I only want to advise products which we're just remarkable at, and that is currently OLTP. Okay. So maybe the right thing is, if there's no other questions, I'll go with my third part of the presentation, which is talking about what I've learned about culture. Victor, does that seem like a good idea?
Yes, sure. Please continue, Mark.
Okay, now let's see if those strange blue lines come back this time. And I hope not.
Don't worry.
So I currently do not see them. So let's go this time.
No, you're okay.
Yeah, that was kind of a unique thing to happen on my presentation. So I believe that if we get the people part of our organization right, the technical part is easy. If we don't get the people part right, everything is hard. And I got to tell you that as a technical person early in my career, I thought that being technically right was what was most important. As an executive, I think getting the culture right is most important. And so to that end, I'm going to put a couple controversial statements in here. Are you running a textile factory in the 1800s where you have people working for you and you tell them what to do every day? Or are you running a modern knowledge enterprise? Knowledge workers want to contribute. They don't need to be told what to do, but you have to build a culture in which they are empowered in the correct way to produce software correctly. First off, I am very passionate that you have to have candor in your culture. You have to speak openly to each other. You have to say truths. And those truths have to be spoken and received with good intent. And that means that managers have to be willing to tell employees the truth about how their business is going so that they can make decisions. And employees have to be willing to tell managers that, hey, the project isn't going that well. We're not going to hit the date. Let's work together as a team. You need to give your employees context. And what that means is developers don't want to come to work every day and put their noise canceling headphones on and just work on a screen of code. Those days are long gone. Developers of today want to know what's going on in the business and they want to know what customers want. And so you have to give them that information so that they can make what I would like to call the micro decisions in an organization. You have to empower those employees. You have to let them make decisions. And sadly, that means you need to let them make those decisions without unnecessary approvals. And so at MongoDB, we have this thing called looks good to me. We don't have approvals. I don't approve engineering plans. I just jump in as a CTO and I say LGTM, and other people jump in and say LGTM looks good to me. And I don't know if that translates very well, but it's different than an approval. And I say to them, well, have you considered this and have you considered this? Now, some percentage of the time that goes wildly wrong and we develop the wrong software. But the vast majority of the time, by empowering employees, it goes wildly right. And the times it goes right are larger than the times it goes wrong. Now, sure, I can tell employees what to do every day, but that means that the velocity of the organization is limited by how smart I am. And it's not limited by how smart my employees are. Now, the problem is that mistakes will happen. And so you have to give people safety. Now, I'm going to tell you, there's this whole meme going around in the industry today about embrace failure. Well, I don't know about you, but that's a great way to get fired as a C-level executive. I don't embrace failure, and I don't think any of you should either. I think you should embrace experimentation, and you should look at what you learn from things that didn't work. It's only subtly different from embracing failure, but it's an important difference. And then what I've found is that employees who you give the top 4 things on this screen to, they will actually beg for accountability. They will say, if you speak honestly to me and give me all the information and you let me do my own approvals and you don't punish me for failure, then I'm going to want to own projects. And so I know this comes across as really preachy and I apologize for it, but I really think that we as executives have to focus on these 5 things. Next, the structure of your organization is really important. And given what time it is, we got started a couple minutes late. I'm going to go through this a little bit more quickly. Are you shipping the right software or are you shipping your org chart? And Conway's law is a law that talks about, I'm not going to read this slide to you, that talks about the fact that we typically ship our org chart. And what that means is that people care about who they report to. They care about who their peers are. And the farther away someone is organizationally, the farther they are emotionally, and the farther they are from a trust point of view. And as I'll tell you in a second, trust is one of the most important elements in developing software. And in particular, if manager A and manager B don't work well together, then the code written by their teams, their APIs aren't going to work well together. And you can see this when you look at products, and you can't understand why some product has 2 different API calls that do almost the same thing, but have different API signatures. It's frankly because they shipped their organization not the right product. Now, this screen is meant to make you laugh. It's actually a comic that was produced in the 1980s or 1990s. And I had actually either worked at some of these companies, such as Google, Microsoft, Amazon, Google, Oracle, Microsoft, and Amazon. I have not worked at Facebook and Apple. And the reality is that these org charts are actually how these orgs function. And so you have to figure out how your org functions. And you have to be able to figure out, are you shipping your org? Are you shipping the right software? Now, the reality is that the beauty of computers is that our creations are actually more complex than we can hold in our brains. And so just like you shard your data, just like you build microservices, you have to shard your organization. And there's a really important number called the Dunbar number. And you can research this, or if you reach out to me on LinkedIn, I will give you the links to the Dunbar research. There's a number of people you can trust implicitly in your life. And this should be used when you organize your teams. And there's circles to it. About 5 people is your family, then 15 people is your close team, then 70 or 80 people is the number of people you trust. And beyond that, it's just a different number of strangers. And it's no coincidence that over the centuries, armies and political organizations and villages throughout the world have actually been organized using numbers like the Dunbar number. So if you have to work with more people than your Dunbar number to get stuff done, you need to reorganize, because that's when politics come into your organization. That's when approvals come into your organization. And there's a developer-only version of this, which I made up myself, which is the single most intimate thing you can share with another developer is an address space, a place where my wild pointer can destroy your code or your data. And what that means is if you are sharing your address space with people you don't trust implicitly, you actually need to reorganize your code, not just your organization. And again, that's really preachy, but I found time and time again, Amazon has its 2 pizza model. And in that 2 pizza model, it says, don't develop code, which more than 10 or 15 people touch. Microservices architecture is all about splitting up your code into little pieces. When you think about constraints on tables in relational databases, we all know why we put those there. We put them so that people can't muck with my perfect table. And this fundamental truth about how the human brain works needs to be factored into everything we do in our organization. Now I'm going to transition to my last point today, which is your customers, no matter what your sales force wants, the customers who have bought your software or bought your service probably want a secure working system more than they want features. Now, I know we all love the shiny new thing, but they all committed their businesses to your software. And so as a CIO or as a CTO, you have to be brave and you have to stand up for your customers, even though you may be tempted to chase the shiny new thing. So nobody cares about how wonderful the features are if it's slow. No one cares about how fast the software is if it's down. And nobody cares about whether the system is up, down, or fast or slow if the data is corrupt or has been breached. Now, the problem is that I've been running software organizations for 32 years now, and people think they need to chase the wrong things. So what I've come up with is what I call my onion of requirements. And I've used this to teach software organizations for the last 20 years. I came up with this at Oracle. Start with security. That's the most important thing, especially in today's world with the internet. I mean, my God, just look at what happened with Okta this week. Look at what happened with Microsoft with their Cosmos DB exploit. Look at what happened with so many people. Entire companies get mortgaged when security is broken. And then with databases, we think about durability. And then we think about correctness. Is the data actually correct? Are we doing the right thing? These are fundamental truths we need to promise. And then think about with the cloud, people now expect things to be up 24/7. No shiny new features here yet. And now think about scalability, the ability to scale out your system. Because the very worst thing that can happen to your organization is when your app gets featured on the App Store and you just became the most famous app in your country and your servers fall over when they hit the 100x leap. We had a customer who had to scale by over 50x overnight, and MongoDB scaled out. Now, I'm not going to tell you it didn't work well. Coinbase, during the Super Bowl, which is the American football contest, Coinbase put up a QR code on the screen, and MongoDB was running that application. We had scaled that application. Coinbase had said they were going to run 10 million transactions per minute, user transactions, signups per minute. We scaled the system to 15 million transactions per minute before the Super Bowl. We hit 23 million transactions per minute for 3 straight minutes. During the Super Bowl, the MongoDB cluster at Coinbase scaled out by tens of nodes right there during the Super Bowl. Operability, that has become so important now, the ability to operate a system at scale. Now, yeah, you got to add features, no doubt about it. But if you don't get these first 6 things right, your customers will feel betrayed. And as a CIO or CTO, you need to be brave and you need to tell the rest of your company about this onion. This is my belief. This is my learning. And so each layer is more important than the one outside of it. And you should be willing, of course you want all of the things in the onion, there's no doubt about it, but you should be willing to give up the things on the outside in order to get the things on the inside. And so with that, I'm done with my presentation today. And in culture, I've talked about your Dunbar number and how to organize your groups. I've talked about what I think is important, and I've talked about how you should be thinking about code and the complexity of code. I really hope this has been useful. And we have 7 minutes left, and I am going to leave my screen up with my contact information on it while we take questions for this last part of the presentation.
Thank you, Mark. Very interesting ending. Thank you very much for sharing your thoughts and knowledge of all these years. So we have a couple of questions in the chat, and then I will follow with you, Rafael. So I will start with Alejandro Arceo. So I don't know, Alejandro, you want to ask directly or can I?
Yes, no problem. Mark, I am interested to evaluate the MongoDB because we are evaluating how to modify the environment that we have running at this moment. Because basically, as I explained in the chat, in the company we have a web application which originally was created for SQL Server by Microsoft, okay? But after that we start using it on production, we found that the performance for SQL was not good enough, okay? Because the level of transactions that we are having in this environment is increasing, and the performance is going down according with the growing of the transactions, okay? But my main question here is there an option to migrate from SQL to MongoDB to take advantage of the, let's say, the performance features that you show us in a smoothly way? I mean, is there an option to install a middleware in the middle in order to move the database from SQL to MongoDB keep running the front end of something like that?
So the short answer is I'm really sorry. The answer is probably not.
Okay.
Migrating off of a SQL database, SQL Server or Oracle, you've got 20 years of business logic already encoded into a lot of what you're doing. We will be releasing, and this is a roadmap. I'm an officer of a public company, so this is a speculative statement. But you could imagine that later this year, we will be releasing some migration utilities that will help you with that process. But the reality is, it's hard. And when I wrote the database migration service at AWS, well, I didn't write it, but my team did. We migrated over 300,000 relational databases off Oracle and SQL Server, and I had to forbid my sales team from ever using the word easy. Now, I'm going to be doing a blog series this year, and that blog series is about how to tear down the monolith. And there's actually an awful lot of real techniques to tear down the monolith where you can slowly move reads off the database, and then you can move some writes off the database, and then you can have a dual write system, and then you can have a dual read system, and then a dual write system, and then you can turn off the old thing. Now, that old system is SQL Server or Oracle. Typically, your commercial agreement with that vendor is probably a 3-year agreement. Most relational databases, I'm just going to tell you, take between 3 and 6 years. And I'm talking real databases, mission critical databases for banks, not some little app at some startup. Most mission critical databases take between 3 and 6 years to fully migrate off. And there's just no good news there. I've done thousands of these migrations. And as much as people want to say, oh, we'll have it done in 6 months, that is actually the exception, not the rule. I'm really sorry.
Okay.
But by the way, MongoDB and other vendors, by the way, if you were to go to some other database, but MongoDB, we have professional services. We are very, very good at the migrate motion. We have technical services. We have education. We do all sorts of things. We might have this migration utility I'm talking about later. I guess the only thing as I can tell you is we'll be your partner on that journey. And the reality is, you have to migrate off that system. We just have to learn how to do it together as partners.
All right. Thank you.
Thank you, Mark. Prissy, do you want to ask the question directly?
Yeah, sure. Thank you very much, Mark, for all your information and comments about MongoDB.
This is mute, Prisciliano.
Hello?
Hello, can you hear me now?
Yes.
Okay, thank you. Sorry, thank you very much, Mark, for your presentation and the valuable information that you are giving us. I have little experience with MongoDB, but in my years of experience, I have been very related to database technologies, like well, you remember Sybase and the SQL Server, and well, the old Sybase of '90s that was working together with Microsoft, and later we had the Microsoft SQL Server, and well, with those kind of database technologies. So I in my experience, sometimes when you are developing applications, the team or all of us are not completely aware of how big will be that database if over the time. So chances are that we are going to need to have a tuning exercise in months or years, depending on how the ground rate of the database. So knowing that MongoDB, as you mentioned, you can program MongoDB with almost all the language that you have. So you can be productive, not not necessarily be a SQL transact SQL expert. And normally, when we are running a tuning effort, we need to target the way that you are writing your SQL statements, the way that you are designing your SQL objects, indexes, views. In some cases, you need to take in mind the memory paging, and you can finish rewriting a complete store procedure or SQL statement to have an impressive rate of optimization. I mean, maybe the SQL statement lasts in the original version 2 minutes, and at the end, after this tuning exercise, it is running in 3 seconds. I have seen that. So knowing the database MongoDB is pretty different in the way that you are productive. How can you do this tuning exercise?
So MongoDB lets you tune the same way. And I know we're at time, so I'll make my answer pretty quick here. MongoDB lets you tune just like any other database. MQL lets you set up indexes, lets you set up things like that. Okay. Just a quick roadmap statement here. We're actually looking into technology by using AI where we will actually be choosing and suggesting indexes. We do that today, but we're making it better. We'll also be doing things where we scale up and scale down your connection pool and scale up and scale down your hardware with serverless automatically. What I'm actually trying to do with my product is make everything you just said invisible to you, where because of the power of AI, I can actually watch how your application is running, and I can actually auto-tune your application. Now, this is all forward-looking statements for technology that we're developing today, but I have dealt with how hard relational queries are for 30 years of my career. And one of my personal missions in my career is to get rid of all that tuning you just said you had to do.
Okay. Yeah, well, it sounds incredible. It sounds awesome because I have never seen that in my career, and I have 3 years too. So, well, it sounds very, very good from the
Thank you very much.
From the productive state. Thank you very much.
So Victor,
Thank you,
if you have to shut things off, Victor, I do want to let people know my contact information was on that sheet. I love answering emails. I love, talking to people on LinkedIn. So don't be shy if I didn't get to your question. But Victor, I don't know if you want to keep going or you want to shut things off.
Only last question, please, Mark. Only 2 minutes, please, Rafael. Can be quick, your question.
Yes, thank you. Well, it was actually 2 questions, but I'm going to go with the one I think that has the fastest answer. And
okay,
Mark, which one do you consider that's your biggest strength? Maybe really transactional databases, or maybe databases that are storing media files, or which one do you consider that's your strongest arm?
So very, very much transactional databases, though we're called a document database, what we mean by that is JSON documents. Sometimes people get confused and they think documents like scanned PDFs. Yes, you can store all those things in MongoDB, but frankly, the place we're best is when you understand your schema and you create a piece of JSON where you can do maybe 1/10 the IO of a traditional relational database transaction in MongoDB. So you get more efficient use of the computer than with the relational database. You get more efficient use of your application. And that's really our core strength is OLTP mission critical applications.
Okay, thank you very much.
Okay. Thank you very much, Mark. Thank you for your effort once again. I know that it's late where you are.
It's 2 a.m.
Yeah. Thank you for reminding me. This is we are very honored to have you. This is a pleasure. Hope you see you soon. Thank you very much to everybody. And we will give the Mark address. Somebody who wants to do more questions. So this is a little recognition for you, Mark, among the lot of you may have. But this is a very special for us, for LATAM, for Mexico, and I hope you like it. We will send you.
Oh, thank you very much. I'm blushing. I really appreciate the time you took today. I know that all of you have jobs. I know all of you have things to do. I actually know it's 6 p.m. where you are, or 7 p.m. now. So thank you so much for taking the time today. I really appreciate it.